welcome to session 3 of the day, which is on building a geological framework for integrated subsurface management. And Francesco asked me to moderate this session because he knows that I love geological mapping. It's what I used to do. I always loved, as a geologist, wandering around in the wind and the rain and making geological maps in many parts of the world. Now I just wander around in the wind and the rain in Brussels, and there's not quite so much geological mapping for me anymore. The closest I get to it is being able to talk about the work of the experts who are working on this in the GSEU project. And it is incredibly important work. I think I have some slides here. That's the other one. Also the green button? Yes, great. So I'm going to show this image again. Because if you think about all of the important geological subsurface data and information and knowledge, just like Chris was saying earlier today, if you think about these things and how they feed into different policy areas, if there's one thing that they all have in common, it's that they require an understanding of the geology, which means that we, the geologists of the European Geological Surveys, must be able to describe the geology. So Europeans speak many different languages, but through geological maps and models, the geologists from across Europe and indeed from across the world can speak this common language. Maps and models are how we can effectively communicate an understanding of the surface and the subsurface. But there are, as Chris also pointed out, different ways of describing and depicting geology. And so a crucial foundational element of being able to develop pan-European harmonized maps and models is to develop common data models, standards and vocabularies. And that's what we're going to dig into a little bit deeper in this session, exploring what is being done and why it's crucial to everything else that we're doing, everything else that we're trying to achieve through this project and a future geological service for Europe. So I'd like to introduce our first speaker, who is Ralf Watzel. He's a German hydrogeologist and president of the Federal Institute for Geosciences and Natural Resources, BGR, which is under the Federal Ministry for Economic Affairs and Climate Action. Welcome, Ralf.
Yeah, thank you, Julia. You put it right. It is the question, where is what? It's the power of spatial information, traditionally in 2 dimensions, and nowadays in 3 or even 4 dimensions if we consider time. And our situation in Europe is that we have done that for the last 100 or 150 years in a descriptive way on a national basis. So we are faced with a bunch of individual descriptions of same or similar issues and features in the subsurface. And in Germany, we have a very particular situation. We have a federal political system. And for the last 160 years, the geological surveys were organized on that level, where we are still today. So as a federal institute, I have 16 regional geological surveys in my back. And they have their independence and their knowledge. And the challenge is to bring it together. And how do you bring things together that evolved over more than a century? And I think that's why I'm invited here to talk on that, because that's a mirror situation in EGS. And as we are dealing with that traditionally, so we made some serious progress. And in the past, it was the standard way of compiling maps. We are able to compile maps. And there are remarkable achievements in the past on the national and on the international level. And that has that follows a certain procedure. And this is like bringing experts together, fencing them in a room for a year or sometimes 15 years. And they have heavy discussions on matching the units, the legend units or the geological issues they are dealing with, they are describing. And I've seen fierce fights about does unit A in country X match unit B in country Y. And this is with goes together with the self-understanding of the mapping geologists. If you have invested so much work and if you spend months and years under the rain and the wind in the field, you are proud of your work. And this is also a psychological perspective, how to bring it together, how to match it with the work of other people. As I said, there are remarkable achievements, and I don't want to criticize them, and we have to keep on track going that way, but there is room for more, and there is also a need for more, because the traditional way, honestly speaking, is not very efficient. And here is where the new technologies come in, and I want to give you an example of what we are doing in Germany, how we approached that challenge, and how we cope with it. Maybe I can switch the microphone. This one, A, B, C, D. That's fine? Okay, so I can see the slides. No? No, it was. Okay. Okay, engineer. Yeah, just watch the figure there. It represents, let's say, the breaking lines along the political or administration borderlines, and we have to bring that together. And typically, what we have, the work of generations of geologists that doesn't fit together in a compatible way, and the main objective is to provide harmonized interoperability of integrated data sets. Okay. So we set up a pilot project in southern Germany with the regions of Baden-Württemberg and Bavaria, and inspired by the BGR. And the goal was to link the general legends of the two countries. They have a region covering a digitized map that is harmonized, well, both are harmonized in themselves. And we are heading for a trans-border harmonization of the 1 to 25,000 scale of that two regions. And then after having done that, we want to proceed and do a machinable downscaling to the 250,000 or 500,000 scale. And this is where the BGR comes in to provide Germany-wide covering data sets. And then in the third step, we want to link that, to the stratigraphic standard of Germany, the so-called lithostratigraphic lexicon. This is a precise, detailed, science-based description of all geological units. How to do it? I got inspired from our geodata manager that has unfortunately left us, and she was talking about applying the technologies of the so-called semantic web. So for those who are not familiar with semantic web, it means putting an expression into a precisely defined context. So Berlin may be a city, the name of a ship, a nightclub, a chess band, and defining that precisely, that is the principal idea of the semantic web. So we wanted to assign unique and persistent labels in the internet wording that's a uniform resource identifier to the general legend units, and we want to define relationships between the units in region A and region B, because this is where the dispute between the geologists is located. And we wanted to do that by a triple structure in the so-called RDF language, the resource description framework, respecting the stratigraphic or geological hierarchy. And it's simple. It's that what you know from your English lessons. It's subject, predicate, object. Nothing more. So you have two nouns, and you the subject and the object, and you define the relationship. That's the predicate. In geological terms, it looks like this. We have a geological unit A in region X, let's say Upper Jurassic, and a geological unit B in region Y, let's say Upper Jurassic, And the question is, are they identical? Or are they similar? Or is one subordinated to the other? Or do they have any relation at all? So, and we set up a workflow. So what we did, we matched the geological legend of the two regions from the 1 to 25,000 scale with that scarce relations to an overarching generic legend. We did it in the pilot area, the first results were promising, and then that was the work matching 1,800 legend units on the one side and 3,300 legend units on the other side. That was the work for two geologists done in 1 month. If the mindset is okay, if it's open and they are committed. So, and next we can do this downscaling. We come back to that later. And this is just an idea to give you a picture to give you an idea how that is implemented. It's implemented in a software, and the name of software is Pool Party, and we run that in the BGR, and all the rest is done over the internet. So here, that's a screenshot from the GUI of Pool Party, and on the left-hand side, you see the legend units, the formations, some information about the matching process, and if we zoom in, I want to have this one, you can see the hierarchy. So if you can't match that formation here exactly with the other, we do it on the next hierarchy level. And if that doesn't work, on the next hierarchy level. And in the end, you match Mesozoicum to Mesozoicum. Yeah? And this is what you see in the 1 to 5 million. Okay. Left-hand picture where we started, right-hand picture where we ended up. So today we have a 1 to 25,000 of Baden-Württemberg and Bavaria, and this is 1/4 of the surface of the Federal Republic of Germany with one unified legend. And to be honest, there is a loss of information. And there's a loss of information in the order of 5 to 10%. And if you, the next step is upscaling, that loss of information is completely irrelevant. So, and that's one example here. We've chosen a pilot area. This is close to Frankfurt City, Baden-Württemberg and Bavaria. And you see the original over there, the 25,000, and then the downscaling by an algorithm that is self-learning, that can be customized down to the 1 to 500,000. And we do that at the moment in an open source process. So we have a contract with the guys in Baden-Württemberg. We work on that and we give feedback to improve the algorithm. Yeah, that's my conclusion. That's my summary. The implementing and applying the technology is very, very promising. The downscaling algorithm is even more promising, and for that reason, the directors of all geological surveys in Germany have decided in fall 2022 to roll it out over entire Germany. So my thinking is about, the name of the project is Consent, and my thinking is about a soil consent, a hydro consent, a raw material consent, and whatever. Thank you for watching.
Great. Thank you very much, Ralph. Excellent. Right. Well, we'll move straight on to our second speaker now, who is Martin Peersmann. He's Program Manager for the Key Registry of the Subsurface at the Ministry of the Interior and Kingdom Relations, BZK, seconded by the Cadastre of the Netherlands. Welcome.
Yeah, thank you very much. Which one is this one or the other one? Okay. Yeah, my name is Martin Peersmann. I'm working at the Ministry of Interior Affairs. Thank you for inviting me. 40 years ago, I was also licking rocks and building up the passion for System Earth as a geologist, sedimentologist. And now I'm carrying the bags of ministers and putting now and then a rock in their bag or an iPad. And I still have the passion, and I see the passion in your eyes and in your stories. But we have to carry out this passion to the policymakers and to the young planologists, city planners, and others, because we are facing a lot of challenges, and society needs your knowledge, but you need to talk the right language. Ik geloof dat deze. Let's take the other one. Can you press the button? Okay. Yep. Now, this is one of our policymakers. She is a very wise lady. She was actually the governor of a province, and she's now in the parliament. And basically what she says, what I told you. Soil and the subsurface are the existence of the foundation of our existence. And we need this because we depend for housing, for water, for food supply, and for energy on the soil and the subsurface. And hardly people realize that. They take it for granted. You walk on the street, you don't know. As a civil servant or a citizen, you don't know. You don't realize. Until things are changing. And that's now. We were facing a lot of challenges. You can only do that by making decisions by using the 3D. A palynologist can tell a story about the Earth. You can tell the story about the Earth in your local city, community, and how they need it. And it's up to you as society to do it. And we put some policies in place, the data-driven policy. You have to understand how policymakers work. Basically, they are in the technical domain. The talks I see today is a lot about the technical domain. Policy making and decision makers is about electricity support and is about public values and public support. You can meet by geoanalysis and geospatial analysis that domain. And you should find that area. Now, remember, data-driven policymaking is the counteract of populist policymaking. With populist policymaking, we cannot solve the energy crisis, the level of groundwater and water and drink water supplies, or housing problems, or a shortage of critical raw materials, or we're not going to solve that. You need integrated spatial planning in 3D. You need real data, maps, visualization, and a lot of knowledge and skills. But you need also be able to talk to the policymakers and the decision makers. It's not only the geological domain, you need some other domains, and you have to exchange that data. So federated data sharing is much more important than a single data hub. Remember that. We use a lot of the APIs. We did all the models recently on the API. We have a huge success in usage of this model because now any municipality in their Esri software or any kind of other open source software, they can use the API and use the 3D models. And now they start using it. You have to take away the thresholds. Now, the policy cycle is not only building the data and the information, but bring it also in the monitoring of the effects of the decisions. So monitoring and sensor data is very important. We have a spatial planning policy, which is about the housing, and in the housing we have the energy transition, the supply, but we have a new act where water and soil are key priority above all the other issues. And this changed the whole game and the importance of the subsurface of the Netherlands. Because now anyone wants to do something on the other issues have to take into account protection of our groundwater, protection of the soil because of our food supply, and not diverting through other areas. So that's where I leave. You see some of the policies on the energy transition, as you were interested. We have our national energy plan, and we are reserving corridors for the energy transition in future, because things are changing and technology is changing fast. Whether we're going to hydrogen or we're going to cold water or heat water or geothermal, you have to reserve the space to act for 2050, 2100, 2150. Things are dynamic. So these are the examples. You can find a lot of data on this key registries. I finish here because politicians didn't know that there were so many offshore platforms, that they are a very nice source of reusable materials and chrome, vanadium, whatever steel. And it's a big employment issue. And you can also use them maybe for hydrogen storage, which is generated from what we did here. This is our ministers, they meet and they can see this platform in front of our ministry. And this is Q13, and we make from excess of wind energy from seawater hydrogen, and we store it in a subsurface oil and gas field, which is then being used for heating the glass houses to produce food. And for them, they didn't know it was so busy on the North Sea as well. And we showed them that if you have CO2 excess, that you can store it in an empty gas field portals, where we take all the CO2 emissions from Rotterdam Harbor and store it in the subsurface temporary. And you link it to the sensors in the cameras in the Rotterdam Harbor. This is the infrastructure of the Dutch state. We can do this. We have this all available for every municipality, province, water board to use it. So it's up to you. And that's it. I stop here.
Thank you very much, Martin. And could I ask our two speakers to take a seat over here where we're going to have the panel session. And I'd also like to invite up for the panel session Michiel van der Meulen, who is from TNO, Hans-Georg Krenmayr, who's from GeoSphere Austria, and Kristine Asch from BGR, the German Geological Survey. Welcome. So, we're exploring building a geological framework for integrated subsurface management. Perhaps I can ask, hopefully. Some microphones for the panel. Okay, here we go. Yes. Great. So I get to ask the first question. So I would like to ask the panel, and anyone is welcome to begin. In a policy context, if you could comment on how a common geological framework is necessary to address current policy challenges, and this might be in the field of water or minerals or energy. Martin, would you like to begin?
For example, in our national groundwater reserves, and we're going to put a protective zonation around it, we have to work together with the Belgians, because in the Kempen, just around the border, the groundwater there is their national groundwater reserves. And in the German, Niederrhein-Saxon and Northwest Rhine-Pfalz, we also have to work together, because else we take their groundwater and their drinking water into the Netherlands. So you have to have cross-border agreements and agree about the aquifers and how you do the protection on it. Because if we protect it, they have to protect it as well.
Thank you.
One example.
Thank you, man. Ralph?
Yeah, I would like to add, if we take into account the topics that are on the table, use of the deep subsurface for storage, for geothermal, for all the other stuff that has mentioned before, that in the first order takes place in the deep sedimentary basins. And typically in Europe, the deep sedimentary basins are transboundary, except of Italy, and perhaps inside Spain, I don't know for sure, but if you go to Central Europe, Western Europe, Eastern Europe, the big sedimentary basins are transboundary. So we need a joint assessment of the features, the processes, and the usage of the deep sedimentary boundaries. And there's something beyond, but I don't want to cover all the topics here.
I dare to start at a maybe slightly unexpected point. I'm now working for an institution called GeoSphere Austria, which is the merger of the former Geological Survey of Austria and the Weather Forecasting Institute, and also the seismologists. And this is why I thought a bit about weather forecasting, which is self-understanding that we have it in place since 10 10th of years and more than that, because it's indispensable for a modern society and economy to know about the weather of today and the next day and the days ahead. And actually, that's the same way how we could look also at geological basic information. So as atmospheric processes do, also geologic processes and geological structures are transboundary, and more we realize that we need this knowledge also for our everyday life. So it's self-understanding that there is a strong political impact and assistance from our expertise more or less directly to politics. To say it with the positive picture was weather forecasting. Everybody understands and will agree that it's needed not only for personal life, I want to know what the weather is like, but also for, as I said, a modern society and economy. On the other hand, there is a negative picture. Think about the situation that you risk surgery because you have a health problem, and start to explore the anatomy of the human body 2 days ahead. Yeah? That's what we presently do with many applied geological projects, which have a strong impact on the underground, combined with risks, and we have no knowledge about it, or nearly no knowledge about it, and we have to change the situation.
Thank you very much, Hans-Georg. Kristine.
Yeah, thank you. Well, I would like to add on a little bit to what Ralph Watzel said, because also mineral resources and ore-bearing formations are crossing political boundaries. So are earthquake zones, so are geothermal energy zones. Any kind of geological unit crosses political boundaries, similar to all those dangers and all those resources. And what I would like to emphasize is the collaboration across political boundaries. I think in order to understand our subsurface better and also to get into the harmonization which we have seen a lot all the morning, we need to have this kind of project, this kind of organization like Eurogeosurveys to better understand the subsurface, which I already said, to get into the vocabularies, to get into the data models, and to talk to each other. And this is the more interesting and the more important, because we have now a war in Europe, and to stand together and to understand each other across political boundaries in any scientific and in any way is a very important thing, especially in those times. And this is maybe not very geological and very scientific, but I think this is something very important in these times. Thank you.
Thank you, Kristine.
Well, there's nothing much left to say, but the very simple summary of what has been said by the others is the European states are very small relative to the structures that are relevant, to us. So I'm talking about the basins, the mountain chains, the fault systems. So the need for a harmonized framework is self-evident. It's very simple, actually.
Absolutely. Great.
May I add
Yes, please.
one aspect? It has not been touched in the way I expected. I mean, in the last couple of years, we have seen that Europe has branched off from Russian gas, and that we are highly dependent on China in terms of minerals for future technologies. And the US, they are doing their own business. Yeah. They are still friendly, but first of all, they care for themselves. So in terms of energy politics and in terms of economic politics, where are the friends of Europe? We are our own friends. So in terms of mineral supply, we have to stick together to release the potentials for domestic mineral supply, not in a single member state, but all over Europe. And with the second perspective, if we want to have a voice on the international platform, it will be not really 1 or 2 member states, it will be Europe.
Thank you, Raoul. I'd like to open up to the audience. Is there anyone who'd like to share their questions with the panel? Any questions? I don't see any hands. Kren.
Yeah, I suppose every time I see a presentation on the Dutch digital models, I don't know whether to laugh or cry, because it's fantastic. Michiel knows this. We discussed this very nicely over dinner the other night. But it kind of terrifies me, the amount of work that's gone into it. I guess within the GSEU, with what we're trying to achieve, the question is, should we just focus on our city models, the urban environment, where the interaction is taking place, where most of the construction is taking place, and we need the geothermal heat, etc., and cooling? Should we just narrow our focus? I mean, rather than trying to, eat an elephant one bite at a time, is that the bite we should be focusing on? And is that where we should kind of concentrate rather than try to reach nirvana right away?
I think we had the discussions in the Netherlands about the 3D and 4D modeling, like also in the topography. So we had this talk about the geographics, and we don't need a high density in a nature reserve in the middle of the Netherlands, which is the Veluwe. We don't need very high models, more than 100 by 100 and half a meter. But in the city of Rotterdam and the city of Amsterdam, there we need 10 by 10 by 1 centimeter. So for line infrastructures like railways, motorways, tunnels, there you need it. And for the cities, urban development. Now we have most of our 1.2 million new houses, about half of them or more will be inner city built. High-rise buildings. And there you need to have, because what do you have if you have houses without warmth? Or houses without drinking water? Or you don't have the sand to build the houses. It's very simple as I say it, but that's how I explain it to my minister. He's responsible for 900,000 houses. And I tell him, nice, you promised the parliament to build 900,000 houses in 2030. You don't even have the sand to build it. And then he's awake. So, but that's where you should focus on. So focus on, prioritize on where you have the most impact on these difficult choices we have to make in society.
Thank you. That's Georg.
I also try to add up to your question. I think it depends on the questions you have. If you are looking for raw materials, it will not help to do a very detailed modeling of any city, because that's not the place to build a quarry or a mine. And it seems that there is a huge potential for deep-seated, non-outcropping mineral deposits in Europe. And to find these deposits, you have to go also to remote areas. And you need true geological expertise, which got lost to a very important branch in our fields, which is digitization and data management. But the same resources we are now missing for regional geologists, for petrology, for biostratigraphy and things like that. And we have to rebuild this kind of resources in our community. And what I also want to add up, it's not only a question of harmonization of existing old and new data. We have a problem with non-existing data. We have to collect data not in archives, but in the field and in the laboratories. And that's unusual to natural sciences. I raised the analogy of the anatomy of the human body. We know this anatomy quite well. That's completely different in geology. So we are lagging behind, and we have to catch up to meet the necessities of our modern society and the energy change.
Thank you. Michiel.
Yeah, just so it may seem to be that we model very consistently over an entire very small country, but we do distinguish between land and sea, obviously. Only for the deepest models we make no distinction. And what you will see in the shallow modeling, so the lithological modeling for building and construction purposes, we have now almost covered the entire country at a single resolution. And as from now, you will see an increase of resolution where the projects are. So there will be a differentiation, but we started modeling with a mapping mindset, so going area by area by area. And now this will change. And I've had the question from other countries who wanted to go for national coverage, and I asked them why. But these would be countries with, for example, Pyrenees in them, as well as the Paris Basin, and I would say that it merits different approaches. Yeah.
Thank you, Kristine.
Yeah, thank you. Hans-Georg, 5 minutes earlier, said that we are also missing data and that we have, I would say, gaps in the data. And for this, and here is a circle to that, harmonized geological maps, overall geological maps of Europe or of a country show, while you're compiling and harmonizing it, what is missing. You show the gaps, you see the white pieces within your surface or in the data that you're having. We know this, for example, from the EMODnet project. While we are having very detailed projects, very detailed data in the marine geology in one part, because there have been very good investigations. And when you compile the data, you see, oh, well, there is a lot of data missing or not there, or only in a very generalized way there, that we still need to investigate. And so this kind of overview data, overview maps for nations or for the whole of Europe are very useful to fill those gaps, which we still have, even if we are having a tradition of hundreds of years of geological mapping all over Europe and all over the world. Thank you.
Yeah, like I don't believe if you go to politicians and say, I need a data acquisition program because I have critical raw materials, give me 100 million and I do some additional data acquisition, you don't get the money. So I'm just giving you, don't want to disappoint you, but I think that's the fact. But what you, once my CEO of Shell was Moody Stewart, he said, we will find more oil and gas in the databases of Shell than we'll found out there. So there's a lot of data around. Use what you have and harvest what the private companies and other initiatives are already gathering. We have an obligatory data delivery. The Geological Survey is hardly drilling a few wells. We had our own drilling crews, we had our own drilling rigs, we had our own drilling programs. We don't do that anymore. We get data from the municipality, from the local provinces, they do the groundwater management, they're responsible for it, they get a lot of data. And if you do it in a harmonized way, you can reuse that. But for some problems like the ultra-deep geothermal, you might have to drill, but then you have to prove that there is no data. Yeah? Michael?
Yes, you're right. So in the Netherlands, data acquisition has become a national effort, basically, rather than something we do as a geological survey. And the value of our data set is way more than what we would ever have been able to spend on data. So that's the way to go. And
yeah, I'd like to comment on that coming from a recent development in Germany. And my message is, if you don't have a legislation on geological data in your country, lobby for one. So we had the experience in 2020. Germany updated its regulation on geological data management. And honestly, we adapted the Dutch model. And now there's a National Geological Data Act that says anybody who's creating geological data has to pass it to the Geological Survey. and they have to care for it, and they have to publish it according to some specific regulations. And there was a huge discussion about that. This is work, this is duty, I cannot go out in the field and do mapping. Say, hey, this is a precious stone, and it will take 5 to 7 years to implement all the operational issues around it, and then it will run. So this is a data creating machine. And let's say the first steps in the direction are taken, and it proves to be right. So if you don't have a legislation, lobby for it.
Okay, thank you very much. And I'd like to, because we're getting close to the end here, just wrap up with something that's already been mentioned, the importance of collaboration, which is obviously very important in this project, very important in EuroGeos surveys, very important in trying to bring together, common language that we rely on for these data models. So what do you consider is still needed regarding collaboration to achieve the goals for a common geological framework for integrated subsurface management? Would anyone like to comment? Kristine? Martin?
Yeah, I still have the feeling you're in this lower triangle. Yeah? You stay a bit in the technical domain. You have to talk and get engaged with the political society domain and ask them, what do you need? If you don't do it, it's not so effective as you hope it to be. So that's my message. Yeah.
Thank you. Yep. Kristine?
Well, this is probably nothing new, but the kind of work what we are doing already across political boundaries in all over Europe, this is a very good thing, and we should definitely follow this up and emphasize that expertise from so many experts from all over Europe are essential in order to get the best kind of information, the best kind of data model. Well, I'm talking now also about vocabularies that you can have for Europe. So this is probably nothing new, but it's just an emphasis of that. It's a good way that we are on, and I'm very much looking forward in GSEU to how it looks like in 5 years' time.
Thank you, Kristine.
Yes.
I have to comment on that as well. You can always strive to be the best, get the best data, of course, but it must be fit for purpose. But we as geologists know, as nobody other, we're never going to dig up the earth. We're never going to dig up till 5,000 meters and map the whole thing out. We have boreholes, and there's 20 kilometers between the next borehole and the seismic data, which isn't there. We have to manage uncertainty. We have to learn politicians and decision makers. What we do in geology is uncertain, you know? And you have certain certainty, it's there, and certain uncertainty, it's not there. And that's fact of life. Climate change is uncertain. Energy transition and all the technologies coming is uncertain. We can do hydrogen and now say ammoniac is the best transport for hydrogen. We can build the Rotterdam harbor and do cracking of ammoniac to hydrogen, but we don't know. Might be us in 10 years' time or 5 years' time, it might be another carrier. So things are uncertain, and cope for it, manage uncertainties.
This is an example where you can observe a different focus maybe of the both of us. So who would accept, as I said, uncertainty in kind of a surgery? Nobody. Who would accept to climb into an aircraft and to fly to the other end of Europe without the good weather forecasting? Nobody. Politics pay for data collection, pay for the institutions because they understand. So from my point of view, it's not to explain them that they have to accept uncertainty. We have to explain to them why it's unacceptable to accept uncertainty, also in geology.
One last word from Kristine.
I like this. This is a real panel discussion. So, Martin, Julie was asking us, what else do we need according to that, what is already existing? And I had said, well, it's already very good. Martin, perhaps what we should emphasize more in our geological community is to get better to communicate to the policies, to the politics and to the government, and to better learn it. Well, you probably can already do it, but geologists who are working more on the technical level perhaps are not so good at it. So this is perhaps something that we can put on our agenda. I don't know how, that a better communication to the policy and perhaps also to the public is something that we should be doing.
Thank you very much, and thank you to all of our panel members and our speakers. A small gift from us for joining us today. Thank you very much. And if you could please welcome thank everyone for their contributions.